Find the saddle point of the function f(xy) equals to 15 minus 3x plus 6y plus x cubed plus y squared. So for the first step, we need to find f sub x and f sub y. So differentiate 15 with respect to x is 0, differentiate negative 3x with respect to x is negative 3, differentiate 6y with respect to x is 0, differentiate x cubed with respect to x is 3x squared, differentiate y squared with respect to x is 0. So now let's differentiate f sub y. Differentiate 15 with respect to y is 0, differentiate negative 3x with respect to y is also 0, differentiate 6y with respect to y is positive 6, and differentiate x cubed with respect to y is 0, differentiate y squared with respect to y is 2y. The second step, we need to equal our f sub x and f sub y with 0. So we're going to get negative 3 plus 3x squared equals to 0. So if we simplify, we're going to get 3x squared minus 1 equals to 0. X plus 1, x minus 1 equals to 0. And our x equals to negative 1 and x equals to positive 1. For f sub y equals to 0, we have 6 plus 2y equals to 0, then y equals to negative 3. So we have two critical points. Which are negative 1, negative 3, and positive 1, negative 3. So these x share the same y. So the third step. So let's find f sub xx, f sub yy, and f sub xy. So for f sub xx, we need to differentiate f sub x with respect to x, which is 6x. F sub yy, differentiate f sub y with respect to y, we're going to get positive 2. And for f sub xy, we need to differentiate f sub x with respect to y, and it's 0. So we're going to use this f sub xx, f sub yy, and f sub xy for d test, which is f sub xx times with f sub yy minus f sub xy over square. So let us substitute. F sub xx is 6x times with f sub yy is positive 2 minus with f sub xy square is 0 square. So we have 12x. So what we're going to do next is we're going to substitute our point into our d-test, negative 1, negative 3. We're going to get 12 times negative 1, which is negative 12. So we know that d negative 12 is less than 0. So it means that negative 1, negative 3 is a saddle point. So now let's check for d at the point 1, negative 3, 1, negative 3, which is equals to 12 times 1, which is positive 12, and positive 12 is greater than 0. So since we're looking, find the saddle point of the function, means that the negative 3 is not a saddle point. So if it's not a saddle point, what type of point is this function? So if we look at the f sub xx, we substitute 1 into 6x, we're going to get f sub xx is positive. So it is a minimum point. So we only have one saddle point, which is -1, -3.